Hello, PLEXOS friends. Thank you so much for having us today, and thanks for coming out for our session this afternoon. My name is Elspeth, and Tari and I are from MISO's Strategic Assessments team. We'll be presenting some of our system reliability attributes work from 2023, and then Tari's going to present how we leverage PLEXOS to that end. So just want to quickly introduce MISO. MISO's job is to reliably manage the grid for the footprint you see on the screen here. It is a rather large footprint from a modeling standpoint. So when we model the MISO system, especially probabilistically with 15 to 30 weather years, and we have our 10 local resource zones, our LRZs, the model gets very large. So the work that Tari's going to present with process automation and things becomes increasingly important. Another thing about modeling at MISO is that our members look to our studies to inform resource planning. So today on this chart, we're focusing on the resource adequacy modeling side, the LOLE side. But as we know, the resource adequacy modeling informs the expansion modeling and vice versa. So our resource adequacy modeling enhancements improve the resource accreditation estimates for our members, which in turn improves the capacity expansion results. The other piece that improves the forward accreditation estimates is capturing system risk more appropriately in our probabilistic resource adequacy model. So we all have heard over and over about how the system is more complicated now with more renewables online and extreme weather events happening. All this is to say MISO's in the same boat as everyone else and that we're facing a more complicated system. So as such, MISO worked to develop a roadmap to address system reliability attributes through exploring the growing risk factors you see on the screen. And to learn more, it's a very large effort, and so to learn more about that, I definitely encourage you to check out the attributes roadmap, and you can circle back with questions about anything you find in there. There's a link there at the bottom. Today we just wanted to choose one of these enhancements to talk about, so we're going to talk about our forced outage modeling and how we captured some fuel assurance through our forced outages. And the way we did all of this is kind of that central question there. The way we analyzed this was by calibrating our LOLE model to the NERC standard 1 day of loss of load in 10 years. And then we introduced these risks to the model and then looked at how our LOLE changed. Let's see, for the 2023 planning year at MISO, our operations LOLE study that's used for our planning resource auction incorporated temperature-dependent outages into the model for the first time. So this slide is looking at that methodology, and there is a link there to the full report for more methodology info. But essentially, historic outage and temperature data were used from 2017 through 2021 on a local resource zone level, so for each of our 10 LRZs. Most of our LRZs show a strong correlation between historic outages and low temperatures. And here on this chart, we're showing our LRZ2, and we're showing coal outages. And this would be all the outages from 2017 through 2021. And we can see a strong correlation there starting at around 10 degrees Fahrenheit. So our operations model used these little linear regressions kind of at the bottom end of the tails. So at a given low temperature starting point, it's adding megawatts of outages to the system as the temperatures decrease. And as a result, in our simulations, weather years with particularly cold winters have these simulated outages showing up. And then they maintain the correlation with our weather year data. And then here at Strategic Assessments, we complicated this a bit more to look at fuel outages. So we wanted to investigate fuel assurance as a risk factor. And we built on this and isolated our fuel outages from the data. The outage data comes from NERC GADS, and as we know, outages are not necessarily consistently reported super well. So that's one downside of the data, but even given that, even given that data problem, we still saw similarly strong correlations as we did with all outages. And so we were able to implement these in our PLEXOS model as well. So on the left here, that chart with the green and blue lines is our simulation of Winter Storm Uri in February 2021. We have all the temperature-dependent outages on the green line, and then the fuel-related outages are isolated from those, and that's what we see on the blue line. And in both cases, the red highlighted area, that rectangle, is where we saw the loss of load in February 2021 in our model. And on the right there, we're showing how the LOLE for the winter season changed, given kind of working left to right there. We have no temperature-dependent outages in the model, and then we added the fuel-dependent outages there is the darker blue column, and then all temperature-related outages there is a lighter blue column. And so we can see that about half of the increase in LOLE that resulted from introducing the temperature-dependent outages was due to fuel availability issues. So again, this is just one little example of one of the elements we looked at, and then I'm going to pass it to Tari to kind of talk more about our process for all of this.
Can you please do the mic check? Great. Okay, thank you. So yeah, we'll be continuing on with the how we actually made this process possible. As Elspeth has introduced, we have tested a lot of different sensitivity scenarios. And just to give a quick update about how we define the LOLE, it is 1 day in 10 years that NERC standard has enforced, but also we have, MISO have implemented a seasonal construct where we are looking at seasons, so 4 seasons in a year, the LOLE level of each season differently. So we can really diversify our projection about different resource adequacies like coming into play as the footprint evolves with more renewable and more retirements, et cetera. To achieve these bulk reliability studies, we have developed this workflow, which I know that looks very complicated. It is intentional. We had to manage, have this RA model that is the kind of base case where we are measuring the LOLE and then doing the fine tuning, which is the feedback loop that you're seeing on the very top. And then we have to kind of move on with the seasonal construct where we are varying the LOLE based on the different time of the year. Once that adjustment is done, we measure the LOLE again and do one more feedback loop for the season, and then we're done at the green box. This has to happen for each scenario, sensitivity scenario that we are testing out. So innovation that we came up with was to tackle the challenge of both having to create this programmed environment in every user, as well as being able to interact with PLEXOS as multi-user-based study platform. So we came up with this Python-based GUI that both manages the run definitions of each sensitivity scenario, as well as managing it for each user who's kind of queuing these studies. Also, it automated the LOLE calculation of both the annual and seasonal construct to make sure that MISO's test scenarios for resource adequacies are what we are supposed to target by NERC standard. One other integration that we had performed was using the PLEXOS cloud integration. This is, so the one before, the slide before, sorry, I don't know how to do this clicker with the back slide, but the one before we were mainly utilizing the PLEXOS Connect interface, which is on-premise for the, thank you, I'm gonna switch back. For the cloud integration, you can kind of picture, well, we're still doing the LOLE studies, so that process, we made sure that that part is modular. We didn't have to reinvent any of that, but the cloud integration is just performing these studies on cloud, as well as managing those multi-user, as well as the run definitions, just as we were doing before. So a couple of the key observations I'd like to highlight is we have kind of noticed that one of the big differences between cloud interfaces and Connect interfaces being the enable of the split runs. So what that means is, if you're doing stochastic sequential Monte Carlo studies, you'll have multiple samples that are doing these different outage patterns or whatever the stochastic variables that you're defining. A lot of times it saves a great deal of time if you were able to split, say, out of 100 runs, 25 runs, do it first, 25 later, do it in another parallel stream. That function wasn't 100% enabled on cloud platform. I think there was some limitation on the PLEXOS 8.3 engine that we were using, so the future stuff is not tested yet. Another part that we noticed was that there was compressed file format enabled for cloud interface only, not on the Connect. which was a big game changer for us when we were doing the post-processing once the models are ready for after the LOLE run. So we were able to do a lot of kind of big data-driven analyses after these runs are finished much faster. Engine time and credit cost for cloud was a bit of a challenge for us because unlike Connect, we were charged by the number of hours that we were running the studies, which are not as transparent when you're kind of queuing the runs. It's hard to tell how long that'll take. The automation at the end, what we wanted to test out was this accreditation, forward-looking accreditation definition. We're calling it direct loss of load metric. The definition of it is on the second bullet there. We had to look at, in order for that construct to be implemented, we had to look at individual units data. For 14 weather years, in our case, that's what we tested it on. So 14 different scenarios as well, 14 different weather year variation. And then it had to be an hourly data as well as sample-wise data for when EUE was actually happening. So that created a pretty large data set that we had to kind of come up with our ways to deal with this solution file because PLEXOS API actually cannot process more than 3 million rows. So, be aware. We were able to kind of overcome this as flat files, but I think eventually a Parquet format or some kind of compressed file that you don't have to read the whole data in, like that would be a great solution. Okay, ongoing work. So when Elspeth was presenting on a previous slide, I think it was slide 3. I'm gonna quickly go back there. Right. So we're envisioning this feedback loop. Right now, this is not like a complete integration in terms of when the expansion model provides some kind of, okay, here's like an expansion model that you want the resource adequacy tested. We're not feeding this back into the expansion model to see whether or not this is kind of reliable or if it changes any of the accreditation metrics. So that would be the goal of this year for MISO, to be able to implement the automated feedback loop between those two and being able to test the robustness of our forward-looking accreditation. We're calling it Forward Adaptability and Visibility Framework. That is kind of in the queue for this year for active development, as well as some of the more advanced data-driven estimation, as well as some machine learning analyses. We have been kind of active in that field for a couple of years. We are hoping to continue some of this development into this year as well. And that's it. Thank you. Oh, we should probably come up. Great. Questions?
Like an external risk process and feeding it in, or are you doing anything within PLEXOS to come up with all those combinations of the 3,000 scenarios or sensitivities for the DLL, OL?
So all the SMC simulations and studies are being performed within PLEXOS. We are doing post-analyses on the data set that we both kind of get out from PLEXOS, right, as like the simulation output, as well as some of the input data we have kind of made for the modeling assumptions. Between those things, yeah, we were kind of able to piece together what are the root causes and type of characteristics that we would like to see. Does that answer your question?
Yeah, I think so.
Did you look at other alternatives, other approaches? I'm a little newer to the PLEXOS tool, but looking at like different models, like the long-term versus the short-term. I was just wondering if you looked at some of the other functionality to run those other modules as well.
Yeah, so that slide with the LOLE model and then the capacity expansion model. So you can think of the capacity expansion side as your LT run, and then that other LOLE model side as ST. Yeah.
I think it's also worth mentioning within the ST studies, I think a portion of it right now is actually being run for MT, like for instance, like plant maintenance. So.
Hi, Charles Rossman, Southern Company. A question about storage and how storage devices are handled in these kinds of analyses. How does MISO handle storage, and are you pleased with the way that it is handled and contributes to adequacy?
Yeah, I think there's always it has the perfect foresight, which is not necessarily the best, but we did enable price following this year with heat rates and fuel prices for our storage. So that was one way we improved that.
Yeah, so for the perfect foresight, just adding in, it was day ahead, one day look ahead algorithm.
Hi, I was wondering, when you showed your stochastic variables, it listed the 8760. Does that mean, did you do any random time sampling too, or was it an hourly study?
It was an hourly study.
Great, and then another question, I guess. For the stochastic variables you did have, did you feed those into the model, or did you use any of the built-in PLEXOS, like max and min options?
Yeah, so the stochastic variables are entirely modeled as built-in. So that we use the random seed feature to generate the force outage. Yeah.
Thank you. Reginald Brett from Southern Company. What type of information are you passing back to your capacity expansion model from your LOLE model to make adjustments in that?
A great question. So that's not part of the presentation right now, so just clarifying that. So what's in the work right now is to pass back the DLOL number as well as the margin, so the PRM numbers, passing that back into the expansion model. That is currently what we are testing.
Yeah, and the DLOL is our accreditation, which in PLEXOS is the firm capacity input.
Amazing.
Any other questions?
Any other questions? Good.
Yeah. Thanks for having us.